Let's make us a tool bit. What I'm doing is milling away some of the high-speed steel tool bits so that it's a little easier for me to grind. I don't have a real narrow width grinding wheel, so I have to make something wide enough I can get in there and use the 2-inch wide grinding wheels so that I can get in and grind some relief on the inside. There's what I milled away. So this is going to be the cutting end right here, so I have to shape this a little bit more. Alright, I'm going to have to give it a little bit of relief on the back side because this is a 1/2 inch wide tool. My groove was 1/2 inch wide, plus you got to take in consideration the radius, so I'll have to relieve a little bit of this just to clear in there. I'll just do that right down here on the end, but I did this so that I can go like so on the grinding wheel. This is where I do wish that we had a a big dowel grinder with maybe like a 1-inch wide grinding wheel on it for being able to do things like this. This will allow me to come in here and dress it though, grind it. That inside edge, see, getting clearance. Alright, that's going to give me enough right there to cut the groove depth anyway. Groove depth would be about 111 to 113 thousandths feet. There's a little bit of radius in that corner from the wheel right there that it's grinding. Looks like I've got enough angle on it, clearance there. Now I can give it a little bit of clearance this way, but I'll touch it up over here on the coarse wheel to kind of remove some of it. Right there at it. The book actually says 0.189. Okay, so I'm going to call that good right there. Basically 3/16. Now I do need to grind this front edge right here too. This is good. This is your cutting edge, and that edge should be nice and square. And now it's just getting the bottom. I need to adjust these tool rests. It's getting a little bit away from the wheel there. Just about there. I need to check it and then put a little bit of relief on this back edge here. Alright, so there's a little bit of the relief to give me some clearance in there in the groove. I have a little bit of wiggle room right there, and it's not going to rub on the bottom of the tool. All I got left to do is to do some honing right there. I may come in here and actually give it some back relief, maybe grind the top of it down and help make a little bit better chip formation. But that's it. Here's what I'm talking about. So we're going to come in here like so. We'll get it in here and centered up, and that's going to go to the back, and we're going to plunge in and cut an O-ring groove right there. So you see why I had to give it a little clearance right here. But I want to try to keep as much metal on as I can to keep it sturdy. But this is going to be choked up real close in this tool holder over here. I'm not going to have it hanging way out like that. I'm going to have it sticking out just enough to get in here and cut that, make it as rigid as I can. All right, we're ready to get started on this O-ring groove right here. I've got everything set and ready to go. We've got our tool mounted in the tool post, and I've already, let me just run this in here close and I'll show you. We'll do it by hand. Clearance here on the compound, something that's always important before you turn anything on, is get things close, rotate it with your hand to make sure that you're not going to jam the machine, you know, and crash it. All right. So the other thing I've done too is I've squared the cutting face of the tool with the work. Now, one way that I did it this time is I just used my little Lufkin square butt right here. All right. And gone in here and I squared it up, and I put a flashlight underneath the tool and look at the light coming through the edge right there. All right, and I've got it pretty well squared up, good enough for what we're doing right there. It's probably not 0, 0 if you was to dial that face in, but it's really, really close. All right, I've got my depth, not the depth, but when we're going to come up in here, I've already touched the back and then set a 0 basically to where I know where I'm going to come in there and cut it. So what I've got to do is touch off on the diameter, set a 0, and then plunge in. Now here's one more thing I'll show you. I usually ride on the compound quite a bit. That's how wide the tool is. After I finish touching up, honing it, is 187, which is right on what we want, 3/16 tool. And then this is the depth. So it's going to go 111 to 113 per side. Okay, that's the depth of the groove actually, is that. So that's going to be 222 on the dial. Once I zero it here, if I go 222, it'll make that depth right there. Okay, that's the proper depth for this 0, 1, 2. I think this is a 2 series O-ring that I'm cutting. So let's go ahead and let's get started. I'm probably going to use the cool mist on this to try to help with keeping the tool cool and also less smoke, maybe a little easier to watch on video. I want to establish a 0, which will be where we start making our cut. I'll run it in there, and once I touch, I'm just going to stop the spindle here. All right, see, that looks pretty square. All right, this will be our 0 point. You ain't going to hurt that high speed by shutting it off like that. So I'm going to 0 the dial, I'm going to 0 the readout. All right, and let's try to get this going. We'll see how that works right there. All right, here we go. Just hand feeding. I'm not trying to go too aggressive, just feeling the tool as it's going in. Feels like I'm getting a little bit of chatter. We may have to slow it down, but so far it's doing pretty good. And the chatter would just be from that little bit of tool hangout. That's why I was saying try to keep it as tight as you can get it. Look at the chips binding up in there. Let me go ahead and stop that. And there's really nowhere for them to go. Wow. The tool's cutting pretty good. It feels very free cutting. All right, that's we're at half our depth right now, so we're halfway there. A little bit more aggressive on the tool depth, the pressure, I'm sorry. And I hope you guys can see this good. It looks pretty good from my end. All right, here's 210 on the dial. We got another 12. There's 220. Alrighty, that's going to be it right there. I'm going to let it kind of scrape in just a bit. Alright, 222 on the dial. Let's see, we'll back it out. Okay. There we go. Let me go get an O-ring and we'll stick it on there and see. All right, here's our O-ring. It's a 256. Actually, this is the right size O-ring, but it's the incorrect type. The Viton O-rings go on here, but I didn't have the right size in Viton. But this is a 256, which is the same size. Bam, there you go. There's your tube seal right there. So the tube for the the cylinder bore, the barrel, whatever, gets pushed onto here, and this O-ring is what seals the hydraulic pressure from coming through the tube and out to the outside. This is a very, very common type with this type of cylinder, tie rod type cylinders. Sometimes they are in the face there, which I actually like better, because whenever these get damaged, it usually pushes those lips in. If there's trash or something in there, or something comes off and it starts hammering it, these are a little more difficult to fix. I have to fix them much like I just cut it right here with a tool bit. Sometimes we have to go and weld them up. So I actually like the face screws a little bit more than this style right here, but they both work good, and I'm just replicating what I've got to make right here. So I do need to come in here with a tool bit and put a little bit of a chamfer there, a lead-in angle, to help line the barrel up as it goes on. But other than that, we'll chamfer this outside edge too, both of these, and I think this side right here will be done. I figured since I was on the subject, we'll go ahead and talk about it. This is a Viton O-ring. It's also called fluorocarbon. That's what it is. It's a fluorocarbon. This is a regular Buna O-ring right here. The Viton or the fluorocarbon style is for higher heat, so it'll withstand more heat than the regular Buna style O-ring. So some applications require a fluorocarbon seal or an O-ring to go in. The piston seals and the gland seals, I'm sorry, the gland and the piston seals are also fluorocarbon. So I just wanted to show the difference. So this was a 256 O-ring, number size. You know, it's a standard size O-ring, number 256. And then the fluorocarbon or the Viton is going to be, I just had it, I just lost it off the top of my head. Let me see. Okay, 568. So this would be a 568-256. So if you wanted a fluorocarbon, 568- whatever the O-ring size is, and that'll get you a Viton. We're going to go ahead and flip this around, get her chucked up, make sure that all of our jaws are clean. I've already cleaned these off. I'm just wiping with my finger, make sure there's no little grit or dust still on there. Same thing with the part. Make sure it's clean. So we're going to stick her right back in here, flipped around. I'm just holding pressure against it. Nylon hammer, and I want to seat these. I just want to make sure the part is seated good against the jaws. You can kind of hear it. It's probably hard to hear on video, but it's sort of a feel and a hear. Whenever it seems solid, it sounds solid, but you don't want to hit it, continue to hit it too hard, because you'll actually get bounced back. The part will hit the jaw and bounce back, so you don't want it to do that. You just want it to stay solid against the jaw.
A-Bomb is a machining god.
Hey, I'm just showing you what Paul taught me. Paul taught me how to do all this. He loves to cut iron. Okay, so we're gonna use my Starrett 670 indicator attachment, and I need a little more room there. We're going to use this to indicate the bore. There's a half a thou right there. We'll go to our low. So on your ID, you're actually doing the opposite of what you usually see me do, or what I say. You're loosening your lows. I'm sorry, you're tightening your lows, loosening your highs. That's tenth right there. That's very, very close. You know, whenever I hear guys like John Grimsmo talking about wanting to hold a tenth on his lathe while he's making his screws and his little parts for his knives, I feel like this is my perfection right here whenever I'm indicating something. And I'm not saying that I'm perfect by no means, but in my mind, I hate seeing that needle move. So I'm always trying to tweak it to get it completely out, which is really tricky. So even though I'm indicated in there, I'm seeing that move probably 1 or 2 tenths, and I'm like, can I get that out? I think I can, you know. So I'm going to come back around here and just barely feel this jaw move. And I think I got it within a tenth closer. So, you know, we're going to call that good. We're going to go ahead and finish out our thickness, which on the print calls for 2-inch 960. We're at about 993 or so, somewhere around there. So we got about 30 thousandths, a little over that. I'll go ahead and get her started. We'll make a cut. Get in here and touch off, make a little pass, and then mic it. So we'll go like about half that, about 15, and we'll mic it. That face thickness is not critical, by the way. Just a target size of what the old one was. Alright, so 973 right there. This will tell you if you're square or not, usually off 1 or 2. About 973, a tenth or 2. There we go. There's about 975, so we're about 2 thousandths out of square. 975. So we'll just dial in 13. We'll call it good. There we go. I'm running a faster feed rate this time. That's helping make that chip curl over instead of just curl up into wads. Don't forget, clean your tools off when you're through. Alright, our next op is going to be a 5-inch diameter by 7/8 deep counterbore on this side here. I already got my depth set. We're just going to have to touch the tool off. I'm down to my last 60 thou or so that I've got to come out of here, so we're going to use our telescoping gauges and a mic. Should be around 15/16. I'm at 938.5. So what I'll do is I'll split it in half, so that's basically giving us 60 thousandths. So I'll do 30 and 30, or 30 and then mic it, take whatever's left. That's going to be a pretty precision fit. That's part of the rod gland seals right there. 10, 20, 30. And I got my speed rate slowed down. All right, let's see what we got. So it's 69.5, so that's going to give us 30.5 thou. I need to make that a little bit over. I'm going to shoot for 2 thousandths over that, so it'll be 32.5 thou. But always double check yourself, make sure you got your measurement correct, and compare them. I'm getting the same thing. So 10, 20, 30, 1, 2 and a half. So as I come up to this face, I'm going to go in 5 thousandths, that'll bring me to 875, and I'll just face it back by hand. I'd say I'm there. I am about 1 or 2 tenths under. All right, so 71 and 9 tenths. I think we're close enough. I'm within John Grimsmo, his area. I'm within the John Grimsmo tolerance, should I say. We're going to do a nice bevel for the O-ring to slide inside this counter bore. Just use a threading tool there, so it'll give you approximately a 30-degree angle there. All right, and then we'll use a boring bar and chamfer that other inside shoulder. The lathe work's done. All we got left is our 4 holes for the tie rods, and then we've got 1 hole that's going to be for our port. I'm just going to finish off this edge from the facing it, kind of sharpened it. I'm just going to use a file. Get them corners. Okay.